respected dignitaries on the dais, eminent scientists, and my dear friends. Since morning we were listening about the atmospheric circulations and the effect of Indian summer monsoon with respect to in context of the Himalayas, in context of the polar regions, and that is only within the limits of the data we have, that is about 100 years the data, and the recent modeling, stimulation, all that. But what I am trying to emphasize on that, what was the paleo monsoon conditions in the Himalayan regime, and we have some research work in the Yamuna River Valley, where I will be discussing about what was the responses of the Indian summer monsoon to the time period of late Quaternary, that is from around 105 Ka to up to 2 Ka time period. So what we have done is that we have tried to find out what are the archives of this such monsoon variability for the interpretation of the paleoclimate within the river valleys. So for that we must look for the some archives. So if you see in this map, this is the Yamuna River Valley, which is flowing across these two major thrusts, that is main central thrust and the main boundary thrust, and these are the patches of the alluvial deposits that we found all along the river valley. And what we have tried to do is that what are the what the information that we can obtain from these fluvial deposits or landforms to interpret the paleoclimatic conditions that has prevailed during the late Quaternary time period. So for that, what we have done is we have identified the different time periods of such aggressive sediment generation or dispersal system within the Yamuna River Valley, and what is the mechanism of such dispersal system. And if we see about the dispersal system of the sediments through a particular river valley, then we must also have some idea about the glacial interglacial conditions, because that is already being recorded. Of course, in the terrestrial environment, we don't have that continuous record, just like the isotopic data from the marine cores or the ice cores. But still, in the river valleys, we have the records, in the indirect records of such climatic conditions in the form of the landforms that we see along these river systems. So we have mapped all this area and try to generate some model that how the fluvial development took place throughout the late Quaternary time period since 105 K. That is the oldest age we have got the fluvial deposit in this area. So for the convenience and to have the better correlation of the data set, we have divided this area into 3 sectors. The sector 1 lies in the north of main central thrust, and also with respect to the geomorphology of this area, the valley is very narrow in the north of MCT, which also indicates the area is exhuming very fast, and it has been exhumed in the past also. So the river cutting, down cutting is more than the lateral in season. So that is the northern part of the MCT, and the sector 2 is that is between the main central thrust and the main boundary thrust. It's a less than Himalayan part. And characteristically, this area that is between MCT and MBT, the valley have a variable morphology of widening and the shrinking. So we have a narrow V-shaped valley also, and we have the wider V-shaped valleys also in this area. So, but these deposits are concentrated mostly on the areas where the valley is very wide, and we have tried to find out what are the reasons or paleoclimatic changes that have led to such type of deposition. And finally, in the south of the main boundary thrust, what is the responses of such fluvial dynamics with respect to the Indian summer monsoon changes throughout the late Quaternary time period. So I will go one by one, sector wise, to show the data that we have generated so far. And basically the work is on the geomorphology, the work is on the sedimentology and the absolute dating of the sediments to have some chronostratigraphy of the climatic events, and finally how to correlate what is the correlation of this climatic changes with the continuous record of the Himalayan isotopic course. So this is the area which is north of MCT. Here we can see a very meager deposits we have looking. The reason is that the area is very narrow and the preservation potential of the sediment is very less. So we have very less amount of sediments. So I will be showing the 3 sections here, which is I feel that maybe the representative to explain what is the. So first of all, the Karsali area, here we have seen that is around 60 meter thick fluvial sediment aggregation, and we have tried to date this thing using the optically stimulated luminescence dating. That this phase of the sediment impulse has started around 47 K or maybe older than that one. This is from here. It is deposited below this also. It is there. So it goes up to 37 K or like that. In the other locality, again we have the similar date of the same paleofructplane level that is confirming the continuation of the same paleofructplane. So then there is another locality where we have got this. This is outlier type of date. That is the oldest one that we have got in this scenario, in this part of the valley, that is in north of the main central thrust. And this deposit is lying over the bedrock, that is in narrow gorge. It is around 130 meters from the present day channel bed. So coming to sector 2, where we have the maximum development or the preservation of the sedimentary deposits in the form of the fluvial terraces, and these terraces are representing different levels from the present day riverbed, and also with respect to the chronology or the stratigraphy, representing the different phases of aggregation. So this is the the scenario in the sector 2, where we can see that up to 7 level of fluvial terraces are there, and these terraces are representing different aggregation packs. T5, T4, T3. This is representing the one aggregation pack. This is another one. So like that we have 1, 2, 3, and 4 aggregation scenarios, or the impulses of sediment generation from the catchment and get deposited in this region. So here also I will be dealing with 3 important sections, which is I feel that representative, and let's see what is the scenario. Before that, this is the area near Workout, and here you can see a different level of terraces. The question arises that why we have such amount of sediment generation within the river valley? Why not we have this thing in the downstream also? So for that, we have in the glaciated regime of the Yamuna river valley, such huge amount of sediment generation might have some indication of glacial retreat from that region, so that the sediment is exposed and ready to come in the fluvial system. So this might be the reason for that, and that I will discuss in later on. So this is the area, and importantly that sedimentary phase it is telling that it is this is sediment is deposited in the form of channel bars. So the transporting capacity of the river was very less, but the sediment generation was very high. So that's the one reason we have such huge thickness of deposits within this part of the area. And we have tried to date this thing, and it came up to we have constrained that this phase it is around 28 to around 24 K, and we have one more date of this same terrace level, that is around 37 K. I will come to it later on. So it is representing the one phase, and the other phase which is exposed because of during the season time period, it comes out to be the 43 K. So this is another phase of aggregation that we have constrained. At the lower levels, again we have the one more terrace level that is around 19 Ka during the Algene time period. So this is the Lakamandal area, which is a very good section here. In this area also, we have got this 87 Ka deposit that is on the top, and it starts around 105 Ka. So this is the major aggregation phase during the interglacial stages. And we have recorded the 3 phases of aggregation. This is the oldest one, that is 87 Ka. It started at 105 Ka, and the second phase, that is around 41 Ka to up to 50 Ka. That is the phase correlated with the north of the MCT. And there is an unconformity in another aggregation phase that started, and it is continued up to the 23 Ka. So this is the scenario of the lower reaches, that is the south of the MBT. Here also we have got the similar aggregation phases, but not the oldest one. It is from the 37 Ka is the oldest date we have got. That is also fan deposit. And on the basis of that, we have seen that. I will skip this one. These are the 4 aggregation phases. Again, we are getting in the south of the main boundary thrust. And we try to plot all these things in the one, and these are the paleocretaceous that which is continuous all along the area. And this is the during the 37 to 24 K. What we are interpreting is that with this in the south of the MBT, that aggregation was happened. The mode of aggregation was the local fan sedimentation, and subsequently there is this influx of sediment from the upper reaches of the valley that led to the different levels of terrace generation. So this is the I will say that concluding slides. In this we have all the phases of aggregation. These are punctuated by the in-season phases. So aggregation, sediment generation because of the glacial retreat, and then in season during the glacial advance because the water is less. So this phenomena has happened since 105 Ka time period. And if we see, and this is also very well correlatable with these warmer phases that has been recorded in the marine isotopic course. Thank you.
Thank you very much for finishing this.